Hello everyone. I'd like to give you a little primer here to help get you started on homework 3. So this is a homework the first homework that's going to use classes and objects, and we're also going to practice inheritance and polymorphism. And it's actually based on some research by Dr. Eric Tachi in our very own Math CS department. He's done some research on mathematical models in invasive species where they're able to introduce what's known as a supermale, which only gives rise to male offspring. And so this is one way you could try to eradicate the species. And we're going to explore it. So while Dr. Tachi uses differential equations rules, we're going to explore this by doing a Monte Carlo simulation, which is just using randomness to try to explore what a possible outcome might be given some simple rules. And so the way we're going to set this up, I'll just scroll down a bit here just to show. We're going to have a class for an animal. It's like the parent class for the invasive species. And then there's child classes of that are a male and a female. So the female can hold a baby during a gestational period and then give birth. You'll keep track of the gender of that baby and how long the pregnancy has been going on and give birth. The male pursues the female and will randomly, if it gets close enough, randomly impregnate a female who's of age and who's not pregnant with either a male or female offspring. But then there's actually a class called supermale that inherits from male, which will have the same behavior as male, but it will only impregnate a female with a male offspring. And so what you're going to do is program, so each animal is going to be represented by a dot on a grid, and you're going to program those dots to move around, and then the males, females, and supermales to have more specific behavior about moving around, like the males pursue the females that are nearest to them, for example. Okay. Now, there's a lot of moving parts here because it's slightly more complicated program than we've seen so far, and so it really does require this object-oriented organization. So I want to show you all the classes that are involved here and how to get started, and also want to explain how to run the animation. Okay. So as always, we're going to pull this code down from GitHub. So I will go ahead and clone this real quick. So if I clone that code, it will make a new folder, which I can then open in Visual Studio Code. And so it's important actually that I open the folder here, because the way that we're going to run this, so maybe first I'll just run it as it is, and then I'll explain a little bit more how to modify the code. But so there's a few different files here. You don't have to worry about the make file. I've already done that for you, so you can just type make when appropriate. But the main file that's going to run this program is the driver. It's called driver. So if I type make, it's going to go through, build a whole bunch of stuff. You notice it made some object files here. And then I can run it. Now, important thing is, I gave you all a port at the beginning of the course. And you might remember in homework 0 that I had you test the software to do animations, and I asked you to change your port. So be sure to use that port that I gave you then here. I'm using 8081, but yours might be slightly different. Okay. Now, once you've built this code, you can run it with /driver. And so it says waiting for incoming connections. Then what I have to do is actually right-click on index.html and open with live server. And so then it comes up with this. You will put in the correct port and then click connect. And let's see, nothing really happened there. Oh, okay. Well, so for me, I'm not actually on Nimbus right now, but you could keep that there. I'm going to use just my address. Okay. Oh no, my address is just 127. Okay, this means, yeah, no, let's try this. Okay, anyway. For you, it's going to be nimbus.science.edu. You just keep it as it is, and then put your port number. All right, but anyway, so this currently is drawing one red dot and one black dot, okay. But we can have an animation going over time. But if you go back and look at the terminal, it will say connection opened and the address, okay. All right, so anyway, that's how you get it to run, and then you know, I can hit Control-C to stop this, and then the dots go away. But if I wanted to start it again, I would just go back and run it again. and then click connect, and it would just bring it back up. Okay, so whenever you want to start this again, just make sure you click connect again, and then it will start accepting commands that are sent to it from your program. All right, so that's just how to run it, but what's actually going on here? I'm going to focus on 4 files in particular. So we have animal.h, animal.cpp, and then simulation.h and simulation.cpp. So let's look at those. I guess I'll start with simulation, actually. So we'll talk about this more in class, but there is a flexible list, like an array list, if you've ever seen this in Java. This is a little bit more flexible than an array. It can grow and shrink. And so what we're going to do is, in a simulation class, we will keep track of a list of animal references that shrinks and grows. So animals will be born and animals will die. And so we will add animals to this and then remove them when appropriate. I'll show an example of adding them in a moment. Then there's also a couple methods provided here. One is to draw a circle. And that one you don't have to touch. But then there's these other methods. If I go and I look at their definitions, you're going to have to fill some of them in. So step is a method that is one frame of the animation. So a certain amount of time has elapsed, and you need to incorporate that. So move the animals along, make the animals take actions, and then finish up for that step. Then we have a constructor and a destructor that you can mess with, and that's pretty much the code. Okay, so mainly just the step method there. You'll probably want to modify the constructor. But yeah, this is the meat of the work that'll be done in the simulation class for the animation. So you want to go through the animals. Now, okay, but let's look at the animal class then. So the way this is set up is a bit interesting. So the simulation has references to a list of animals. The animals themselves actually have a reference back to the simulation. And the reason for that is because an animal may need to know, so the simulation is kind of for holding all the animals in one data structure in one place to look things up. But an individual animal may need to query the simulation and figure out, like, so for example, if I'm a male, I may need to query the simulation and find the closest female. So I need to be able to go back and look at all the animals. That's part of a design constraint here. And I also need to be able to draw myself. So the simulation is the class that has the method to actually draw circles. So part of the simulation is this canvas where things are drawn. I don't want you to actually touch this code here. But, oh yeah, and I also provide another file, canvas. You don't have to touch that. That's the code that communicates with the browser and draws things. But yeah, the animal has to be able to call methods back in the simulation class. Okay. All right. So right now it's a bit boring here. It's just drawing 2 dots. But maybe what I'll do is I'll set up a few animals in this list of animals to begin with. So let's see. So for the constructor for an animal, I'm going to have you randomly initialize their position on the grid. But for now, I'll start by at least putting in their x coordinate and their y coordinate. And maybe I will, just for now, I will make their x and y coordinate be 0.5. Okay, so they're going to be at the center of the canvas. 0 is to the left, 1 is to the right. And then 0 is also top, and then, or no, 0 is bottom, and then 1 is top. Okay. All right, so anyway, I'll put them at that place on the canvas. Let me also define a method called draw, perhaps. You know, you actually have some freedom in what you want to do here, but just to show you how these 2 classes interact together, I'll make a method called draw, which draws a dot at that position. So I'll go implement it here. So animal, so it's the draw method that belongs to the animal class. And what I'll do is I'll reference back to the simulation, and the simulation class has that method circle to draw a circle. So let me call that. So it has this method called circle, and I'll pass along the x variable and the y variable. as the center of the circle. I'll make the diameter small-ish, and maybe I'll make the circle be blue for now. So I'll say 0, 0, 255. Okay. I've done enough code. Let me just build it, make sure it builds. Okay, there's a problem. Oh, okay, simulation is actually a reference. so I have to dereference this and then actually have to dereference simulation. Okay, so I made a mistake there. So simulation is a reference. I have to dereference it and then access the circle instance method. Glad I checked that early there. So let's make this. Okay, now it made just fine. But there's no, I'm not actually adding any animals to the simulation yet, but I have the functionality to create one and draw one. So what I can do is, in the constructor for the simulation, I can add some animals to this list of animals. So maybe what I'll do is I'll say, okay, in the constructor, I will say for int I equals 0, I is less than 10, I plus plus, and I'll say animals.push back new animal. So pushback is a method in the list class that adds something to the end of the list. And so here I'm adding a new animal. Okay, let's build again, make sure that was okay. Seemed okay. Oh no, we have an error. Because, okay, very important. As I said, the animal holds a reference back to the simulation that contains it. That means I have to pass along the reference to the simulation that the animal is living in, which is this, right? So this is a pointer to the simulation that the animal belongs to. Okay, now it built just fine. Okay, so when I make a new animal, I have to pass a reference to the simulation that contains it, which is this, because I'm creating it in the simulation constructor. And then in the animal class, I save away that simulation reference so that I can access it later. Like in a method here, if I need to draw something or query something else in the simulation. So it's interesting. Again, the simulation holds references to animals, but the animals also hold references back to the simulation. So these two classes kind of talk to each other. Okay. And then one more thing, I guess, in the step method, what I'll do is I'll loop through all the animals. So looping through this list object is a little bit weird. Just bear with me for a second. We'll talk about it more in class. But I have to create something called an iterator. And I'll say animals.start, or sorry, animals.begin equals animals.end IT++. Let me make sure I got that right. Yep, that's all good. Okay, so we start this, it's called an iterator. We start this, it's like a cursor, like a pointer that goes through the elements of the list. That starts at the beginning there. And I'm going to loop through all the animals and I'm going to draw them. So I'll say maybe animal star A, or animal, maybe I'll call it. So what I have to do is take this animal out of the list. And it's actually, it looks like this. I have to dereference the iterator that's going through the list and then cast it as the appropriate type. So I built that, that's all okay. So this is how I take something out of the list. And now I can call methods on it. So I can say animal draw. Okay. So let's try to run this real quick. All right, so this is, again, this is at every animation step, this is just looping through all the animals and drawing them. So this is how you loop through the list, and this is how you take an animal out of the list. Okay, so when I run this, it's waiting for incoming connections. Let me go back here, change my port to whatever my port was. Actually, again, you'll be able to keep Nimbus, but I'm going to do something different. Okay, so it just seems to draw one blue dot at the middle here. And that's actually, there should be 10 animals, but they're all on top of each other, and they're all being drawn as a blue dot with radius 0.05. Let me make the radius smaller, and just for the sake of illustration, maybe I'll add to the constructor a specification. Or maybe, actually what I'll do is I'll add like a setter method to set the x coordinates. So I'll say maybe void set x, float x. And so let me go back and set, let me implement this method. I'll say this x equals x. I should probably do a little bit of validation here. Maybe I'll say if the x coordinate is greater than or equal to 0 and the x coordinate is less than or equal to 1. Those are the valid coordinates on the canvas. So I'll do a little bit of validation in the spirit of information hiding and protection here of these variables. And what I'll do is in the constructor is maybe I'll make an animal, but I will actually, so I'm dynamically allocating an animal here. But I will actually, I'll call the set x method on it, and I will set the x coordinate maybe to be I over 10 or something. So I'm going to say float I over 10.0. So now it's actually going to change the x coordinates of these different animals. Okay, so let me kill this, Control C. I'll build this again. And I will go back and run this. So when I do that, now I see that, oh, actually not only the x coordinate was changed, let's go back and look. It looks like in the draw method I was accidentally using the x coordinate as the y coordinate. Okay, so let me fix that real quick. The y coordinate should all be 0.5 because I never changed them. I only changed the x coordinate. Okay, but anyway, now I go back and now I see these lines in a row here. Okay, or sorry, these dots in a row. All right, so zooming out again, we have this simulation class that contains a list of animals. We have this method that gets called every step of an animation, like these might eventually move around. And then I have an implementation of behaviors in the animal class. And that class actually contains a reference back to the simulation class, so I could do things like draw or query for other animals that are nearby. Actually, maybe I'll show you one more little thing here. So let's say that I also, in addition to draw, you probably want to make a method called action. So based on the amount of time that's elapsed, you'll want to do something to that animal. So maybe for now, what I'll do is I'll just move the y coordinate up by dt over, I don't know, 50. We'll start for now. So the amount of time elapsed over 50, I'll actually move the dot up a little bit. I do have to make sure I then call that method on the animal at every animation step. Okay, so I'm going to call action with the amount of time that's elapsed and change the y coordinate a little bit. So I just wanted to show you what an animation would look like when I actually change some of the variables every step. So if I look at this, so you get these dots slowly moving down. Okay, actually I think I was wrong. The y coordinate of 0 is up here and the y coordinate of 1 is down here, but that doesn't really matter for your purposes. Okay, so anyway, these dots are all moving down now because in the animation loop in the simulation, I call this action method, which adds something to the y coordinate, and positive y is down. Okay, so I can always restart that simulation, do Control C, run the driver again, and as soon as I connect it, it'll start again. All right, so that's the assignment, and then so you're going to work through adding different behaviors. The first thing I want you to do is actually add a couple variables for the velocity. So to keep track of not just moving this thing in one like a straight line downwards, but initializing random directions of these species, and then updating their position based on the direction they're moving in. So you'll end up with something like this, and you'll have them bounce off the side. So once they reach a boundary like x equals 0, x equals 1, or y equals 0, y equals 1, they're supposed to bounce off and go back the other way. They also can have an age. So you keep track of them, and once they get old enough, they will get drawn bigger. So notice they're drawn a little bit smaller here. These are considered children. They're not old enough to mate, but now they're big, and okay, they're big enough to mate and to be pregnant. And then the last part of the first chunk of the assignment is getting them to move near each other, and that's a warm-up to getting the males to pursue the females eventually. So you'll implement that behavior in the action method. And then you'll go on and you'll implement some more specific behaviors for males and females. So here the females are drawn in that reddish color, and the males are drawn in blue. And then pregnant females who are pregnant with a female are drawn in magenta, and pregnant females who are pregnant with a male are drawn in yellow. And then eventually you'll add the super males, and those are these cyan dots. So you notice that the males and the super males will pursue the females, you know, they'll alter their direction to pursue the females that are closest to them and try to impregnate them. So that's the behavior that you have to implement. Okay, so I hope you find this interesting, illuminating. People have really liked this in the past. It's given them ideas for their final projects. So I hope you enjoy it too, and please continue to ask questions on Discord and try to work through this stuff. All right, talk to you soon.